أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. Today we'll be talking about cognitive science, artificial neural networks, connectionism, and symbolic cognition. So these are fairly complicated theories in cognitive science which derive from neuroscience, and we will explore a few books very briefly and some papers. So first one is Microcognition by Andy Clark. This gives a nice overview regarding distributed processing and cognitive science and connectionism. And next we'll be looking at a couple of pages from The Innate Mind, which speaks about cognition and intelligence. Thirdly, we'll be looking at Image and Brain, another influential book, in a bit more detail with experiments that utilize different models. And last but not least is Shank's Psychology of Associative Learning. So the idea is to offer a wide range of perspectives, and from that point onwards, we will draw a conclusion which allows us to enhance our understanding a bit more. Because at the end of the day, the difference between a good scientist is that they explain things, and a great scientist explains things simply. So I, inshallah, aim to be the latter as soon as I can and as comprehensive as I can. So, first and foremost, we'll look at Stanford Encyclopedia. This is the best source for anything to do with philosophy, anything to do with scientific definitions, and this I find is better than simply Googling or using an AI model. Yes, you get a response, but it's not a comprehensive and brief response, in my opinion. Anyway, so what is connectionism? Connectionism is a movement in cognitive science that hopes to explain intellectual abilities using artificial neural networks, also known as neural networks and neural nets. Neural networks are simplified models of the brain composed of large number of units, the analogs of neurons, together with weights that measure the strength of connections between the units. These weights model the effect of the synapses that link one neuron to another. Experiments on models of this kind have demonstrated an ability to learn such skills as face recognition, reading, and the detection of simple grammatical structure. Philosophers have become interested in connectionism because it promises to provide an alternative to the classical theory of mind. So, the theory of mind, very briefly speaking, is an attempt to empirically, using physical evidence, to explain abstract thought patterns. So, for example, how do I know the difference between a dog that's an animal and a bird that's an animal? Theory of mind it dictates that it will try and discriminate and distinguish between the parts that make up the whole. So, connectionism is now entering into the conversation and stating, hey, we can offer a coherent model across the board, whether it's linguistics, whether it's creating networks that transmit knowledge similar to a train network, for lack of a better example, for knowledge acquisition, knowledge creation, and also in robotics as well. So the widely held view that the mind is something akin to a digital computer processing a symbolic language. So what is the symbolic language? DOG. So for example, I'll give a demonstration here. So if I write this here, you instantly recognize the word, you recognize the alphabets, you recognize the structure. This is not a mere accident, but this is a strenuous and an intellectual effort on your part and cognitive load on your nervous system. And if I ask you, is this a dog? And it's not a trick question. And if you say, yes, it is a dog, from a connectionist point of view and from a theory of mind point of view, you're not exactly wrong. However, from a pragmatic, practical, and real life point of view, obviously, this is not a dog. So, what makes up a dog are, let's choose three features very briefly. Okay. So, so we've taken three features here. Dog has four legs. Okay. It barks and it has a tail. So, these features, they don't make up a dog, but they are parts that make up the whole. Now, the idea of connectionism is they attempt at breaking down how do you know D, how do you know O, how do you know G, okay? And with this arrangement here linguistically, DOG, how does your brain pick up that, okay, this is dog, not, for example, OGD, OGD, or some other mumbo jumbo going on? How does your mind know that this is a coherent word right here? Okay, and we will very shortly see an example of alphabet recognition, and I'll share a model with you right now. So this is looking at how the letter T, right, T for Tom, is represented on a grid, and how through a connectionist model it's trying to explain how your mind picks up the right shape and recognizes the letter T. So this is an architecture. So in neuroscience, architecture means a system or a model by Koslin from the 80s. So he's one of the individuals that developed this early on, and it's still used to this day, despite many scientists being associated with Epstein. There's no surprise there because this technology is literally used. Sorry, this model has literally given birth to technology that's being used in fiber optics, in logistics, transportation, big data, so on and so forth. So this is the model here. Okay. So the idea is that the letter T, right? Here's the retina. So retina, your eye, looks at letter T. It's broken down through a complex system of neural networks. So you have the first layer, hidden layer, output layer, and then from here, the position of the dark square. So this is the part of the whole. Whole is letter T, part is a small square. And then they do another control experiment looking at different shapes, which are not exactly alphabets, but they do have some coherency. For example, this plus sign, right? This X sign. So they aim at comparing these various models just to get the best result out. So I will discuss this inshallah as we go on. But this is just to give you a general idea. So this is one part of cognitive science, and the complete opposite of this, you can see a view that contrasts this, not necessarily contradicts it, but contrasts it. I'm of the opinion that they complement each other, which I'll discuss towards the end. But the other view is called symbolic cognition, which literally states that we don't need any of these models. The function of the word itself allows the mind to understand. So, for example, if I, to give another simplistic example, if I write here, if I write this with an expression at the end, why question mark, that's an incomplete statement. However, this in psychology is called a cue, something that's shown to evoke an emotion or a response. Okay, naturally, in most cases, one would ask, why what? In reference to a situation, which could be a negative one, or it could be a reactive question, so on and so forth. So, symbolic cognition says to a degree we can explain this by using other propositions. Why am I late? Why am I a male? Why am I not an atheist? These type of l- logical statements and inductive discussions and deductive explanations can be broken down very simply. So hopefully that gives some insight to everyone on YouTube and everyone everywhere else as to why this is a big deal really, and unfortunately many Muslims are not part of this discussion. At least in the academic circle there are some, but when it comes to breaking these concepts down in a simple way and allowing others to step into this field, it doesn't exist. So, inshallah, my aim is, with all the difficulties that will come with this and the difficult position that I'm in and will be, and I might get out of and then might be thrown into another one, bismillah, we remain positive, have hope, and do this for the sake of Allah, fi sabilillah. Anyway, so going back, quote, exactly how and to what extent the connectionist paradigm constitutes a challenge to classicism has been a matter of hot debate in recent years. So yesterday we spoke about paradigm shifts. We looked at Kuhn's perspective on this, and we looked at Aristotelian logic. So that's why at the end I discussed cognitive science and paradigm shifts that exist there, right? They academically they're called scientific revolution because when something new comes to the surface after years and years of experimentation and deduction and induction, obviously, and going through the entire scientific process, like the George box diagrams I mentioned, I showed, there seems to be a revolution, and then there's a violation of a category. So, where do you put theory X, which is a new thing, completely be part of the conversation, or should it be ostracized, or should it be isolated? So, these things are always happening in science, unlike the religion, in particular Islam. Such a thing does not exist. If Allah states something is haram, it is, irrespective of whatever happens in the future. You can grow lab meat which tastes like human, but it will never be halal or taste like chicken. And no surprise, Scumrow are the leaders when it comes to lab grown meat. So you can't really connect this concept with socio political and economic situations. Anyway, so description of neural networks. A neural network consists of large number of units joined together in a pattern of connections, like the one I showed you earlier, with the circles and the entire grid. Units in a net are usually segregated into three classes. So you have your input unit, which receives information to be processed. So imagine a door. Output units where the results of the processing are found. So imagine an exit. And units in between called the hidden unit. So if a neural net were to model the whole human nervous system, so this is the attempt, this is what they're trying to do, is create a very complex system Allah has created, which is a human nervous system, and put it onto this model. So if they were to do this, the input units would be analogous to the sensory neurons. So sensory neurons are, for instance, your eyes. That's the most researched area in neuroscience, which is the visual system. You have your olfactory, which is your nose. You have your bioral, which means both ears. You have your taste, but the most well researched thoroughly